Welcome students. In this video we'll do the following calculus exercise. Please subscribe. Computing the instantaneous velocity. Here's the problem statement. Suppose you have a function that represents the position of an object over time. The position function is given by. So here's the position function that we're looking at. S of t is equal to 5t squared plus 3t plus 2, where S of t is the position in meters and t is the time in seconds. We need to find the instantaneous velocity of the object at t equals 4 seconds. So from physics we know that velocity the instantaneous velocity is equal to v of t is equal to ds dt, which is equal to the derivative of the position. Okay, so that's equal to d dt of 5t squared plus 3t plus 2. Since this is a polynomial function, we can separate each term and take its derivative, and we can use the power rule for these ones. So we can do as follows. So that's equal to d dt of 5t squared plus 3 d dt of t plus 2 d dt of 2. Okay, so the derivative of a constant is 0. The derivative of t is equal to 1. So 3 times 1 is 3. Now here we use the power rule. So the 2 comes down and we get 2 times 5. So that will be 2 times 5, which is equal to 10. And then we have 10 times t. Okay, so now the whole thing is equal to 10t plus 3. Okay, so now we have the velocity function. V of t is equal to 10t plus 3. That's the first thing. And we need to find the instantaneous velocity at t equals 4. So all we need to do is plug in. We need to plug in at v equals 4. So that's equal to 10 and then 4 plus 3. So that's equal to 10 times 4. I'm sorry, we already did that. Okay, so 10 times 4, that's 40 plus 3, which is equal to 43. And then so we're talking about meters. meters here. Meters. And the time we're doing in seconds. That means that our answer has to be in meters per second. So that our instantaneous velocity is 43 meters per second. So the derivative of the position function gives us the velocity function, which we can use to find the instantaneous velocity at any point in time. In this exercise, we found the instantaneous velocity at t equals 4 seconds. The object's instantaneous velocity at t equals 4 seconds is 43 meters per second. Understanding how to derive and evaluate these functions is essential in many fields such as physics and engineering. Thank you for watching. Please subscribe.